This question is referencing the 1988 Junior Maths Challenge question about weighing a baby on some scales and the subsequent things that happen. So 21 years later, they're referencing it, and the baby was 5 kilograms but has increased to 50 kilograms. So that means there's been an increase of 45 kilograms, and therefore, if we divide by 5, we see how much it's basically gone up by, and the weight has increased by like 9 times. We've added 9 lots of the weight onto the original. Now, what that means, every time we add on 1 lot of the weight, it's increasing by 100%. So the answer is going to be 900%. Let me just say a little bit more about that. So if the weight had gone from 5 to 10, then we'd look at the difference there, and it'd be 5 over 5. The weight has increased by like 1 of itself. That would be 100%. It's doubled. Let me talk about one other way of doing this question. It uses the idea of multipliers, which you may or may not be familiar with, which is why I've talked about it second. So let's say I've got 6 and it's increased to 9. Now, rather than finding out the difference, I can just do the new divided by the original and work out what my multiplier is. What can I multiply 6 directly by to get to 9? And the 1 basically represents 100%, the original amount, and then I can write it as 150% and see actually it's gone up by 50%. So from the multiplier, you can just look at the 0.5 and see that it's gone up by 50%. Or you can equivalently like minus 1 from 1.5, and then you end up with 0.5, and that is your increase. Because let's look at what happens in this case. We do 50 divided by 5, the new divided by the original, and we get 10. So the multiplier is 10, which is actually equal to 1,000%. But remember, that includes the original, so we now need to minus 100%, which gives the 900%. Or equivalently, you can look at the multiplier, subtract 1 from it, you get 9. That is your 900%. It's just a little bit harder to see, I think, than when you have something like 1.5. Okay, anyway, there's two ways to do it. I hope you're happy with one of them.